Okay, guys, so this is part 3 of lesson 2, reduction formulas. Okay, here we have another example. Okay, so as you can see, again, there's my X, Y, and R boxes. One of the boxes is going to match that point, and the other one will match that point. Guys, here you can see, there we have R. From here to here we have R, same this side. These two angles again have the same name because they are exactly the same value. Okay? The same angle, so the same value. Okay. Now, here we have angle theta, and we have 180 degrees plus theta. So we're going to start here. It's going to go up until the 180 degree line plus this little corner up till here, or this little angle, theta. So, okay. Your coordinates for this point is 4 and 3. You can see it's the same coordinates as here. Okay, which means it doesn't look here because it's not drawn on scale. But this angle, theta and theta here, they're the same size. That's why I used theta again here, theta, and I didn't use alpha or beta. Okay. So let's let's try to explain this. Okay, first of all, let's get the coordinates of x and y over here. Okay, again, R was calculated using Pythagoras. Okay, guys, if these two angles are the same size and they both stop at the end, or the points stop at the end of the circle, obviously this will have exactly the same coordinates, only the signs will maybe differ because x is minus here and y is minus over here. So x is going to be minus 4. Y will be minus 3 and R is always positive, so that will be 5. Okay, so sine of 180 degrees plus theta, so sine of that angle. Okay, sine is y over R. Okay, we're going to use this angle, guys. We're working with this one, so we're going to use this block. Okay, minus 3 over 5. Okay, cos is x over r, so it's minus 4 over 5, and tan, I'm just going to write that one here, is y over x. That will be minus 3 over minus 4. The two minuses will cancel out, so it's going to be positive 3 over 4. Okay, so here we have sin, cos, tan. Okay, now I'm going to show you something interesting. You see here, sin theta, the original angle, which is the same as this one. This one just looks smaller, but it's not drawn to scale. Okay, so these answers will match the answers that we work out if we work out the answers for this little sketch. Okay, that's why I'm using it here. 3 over 5 for sin theta. Here we have sin for 180 degrees plus theta is minus or negative 3 over 5. So it's exactly the same answer, only the signs differ. Why is this, guys? Because sin is negative in the third quadrant. Okay, here we can do the same. Cos for theta is 4 over 5, and cos for theta over here for this angle is negative 4 over 5 because cos is negative in the third quadrant. Tan, 3 over 4, 3 over 4 over here. They are exactly the same because tan is positive in the first quadrant, and this one was in the first quadrant, this little one, and also positive in the third quadrant because CAST, tan, falls in the third quadrant when it's positive. So we have a positive answer over here. Okay, let's try this one also. Okay, what we have over here, guys, it's again exactly the same coordinates as the previous one. So theta is again has the same value as the previous sketches. Now they give us this bigger angle. So it's 360 degrees. That actually has to go all the way up until there. So we start here, and it goes around up until 360 degrees and then back again. So we go around the plane minus that angle. Okay. So, and there's my matching X, Y, and R. Let's do the coordinates of this one, guys. They are exactly on the same place. Y and X will be the same for both of them. Only the signs will differ. X here is positive, so it stays 4. Y here is negative, so it's minus 3. Okay. So let's see. Sine 360 minus theta. Again, sine is y over r. Y is, now we're going to do this one, this angle. Y is minus 3 over radius, always stays the same and is always positive, 5. Cos is x over r. X is 4 over 5. And tan is y over x. That is minus 3 over 4. Okay, now you can see, guys, which one in the Cartesian plane, sin, cos, or tan, is positive in the first quadrant. This is the first quadrant. Cos is positive because CAST, and you see we have a positive answer over here. So it's positive. And all the rest in this quadrant are negative. Okay. So yeah, I made you a little summary. Here's your cast plane. You can write this down, guys. You have to write everything down anyway. So if you write this, you basically have everything. So cos of 360 degrees minus theta in this quadrant is positive. Theta in the first quadrant will be positive no matter which angle, or not angle, which one you work out, whether it's sin, cos, or tan. Again, sin and tan are positive over here. And then these are easy to work out by yourself because this is a 180 degree line. So if we minus an angle here, it's going to fall into this one. If we plus an angle with 180 degrees, it's going to fall into this quadrant. And 360 minus theta will fall into this quadrant because we will go around up until that 360 line minus an angle. Okay, guys, remember we only work with a 180 degree line and 360 degree line in reduction formulas. Okay, so only 360 and 180 minus or plus an angle. That is how you're going to recognize these, the reduction values or formulas. You're going to see this and you're going to see that. Then you're going to always know that you have to use this little summary over here. Okay,